for joining. So I am Parthasarathi Balasubramanian. I am working as a cloud infrastructure architect, mostly focusing on the migration, security, and financial operation. My roles and responsibilities setting up the foundation infrastructure for the top 500, Fortune 500 healthcare and life science customers. Today I'm going to talk about something about AWS Network Firewall for the egress traffic control. So most of the time, all our customers protecting their ingress traffic through WAF, Web Application Firewall, or any other third party. But most of the time, all the customers are not protecting the egress traffic, so they don't have any control over it. So today we are going to talk about some of the agenda. So what is egress security, and overview of AWS Network Firewall and deployment models, and why AWS customers are spending time on the egress traffic, what is the necessary, and a couple of network firewall deployment best practices. So what is egress traffic? Egress security. Egress connection is something network request initiated by the VPC workloads, maybe your EC2 instances, not just the response to the ingress traffic. Maybe sometime it's a workload designated to the internet, like downloading some patches or reaching out to the third-party application hosted outside the infrastructure. Those are categorized as the egress traffic. So, okay. So this is a typical web application architecture for the ingress. We will have the application deployed in the private subnet, and in front of the web application, we'll have the application load balancer to protect the actual EC2 instances, and it's connected to the internet gateway. So end user can reach the application load balancer, and then it forward the traffic to the backend workload application, so EC2 instances. How we can protect the ingress traffic? So we can have a AWS Web Application Firewall in front of the application load balancer, so that if any attack comes, then we can protect the Web Application Firewall as well as the EC2 instances with help of WAF. WAF is layer 7 protocol. WAF works on all the web application filtering, DDoS attacks, everything. Also, the same application needs to, so even it is a public facing application, also the same application needs to reach the internet to get the patching or integrate with the third party SaaS application or partners. So that's why we need internet access. So most of the network traffic that usually going through the NAT, if it is need to reach the internet, right? So what we will do, we will have the egress traffic pointing to the NAT gateway, and the NAT gateway pointing to the internet gateway, and internet gateway forward the traffic to the internet. So in this case, we don't have any control. So all the traffic forwarding to the NAT gateway, it will be forwarded to the internet without any filter. So in this case, how we can protect? In this case, we really need a filtering as well as the visibility, what the traffic going outside, if it is log4j attack or a C2 command and control attack. So how you are going to mitigate, stop all these attacks. So before we implement the AWS Network Firewall, so how we managed all the egress traffic? We, not as most of the customers using the Squid proxy. It's an open source proxy with the NAT gateway. So the problem is Squid proxy running on EC2 instance, you have to patch the EC2 instance, and it's open source, you have to update the binary files. And you don't have a inspection capability. There is no IDP, IDS inspection since it's open source. And the restriction via only the NACL. So the security control we have only on the NACL, Network Access Control List, and security group. So beyond that, we don't have any visibility and control to restrict that actual traffic. And most of the problem with the Squid proxy, we need to patch and relaunch the EC2 instances frequently, just to make sure your proxy is updated with all the patches. So most of the time, we use the Squid proxy only for the URL filtering. So we don't do any inspection, deep packet inspection. We can't do anything. So what is After AWS released the network firewall, so we started looking at how we can use the network firewall to block the traffic, also do some kind of a TLS inspection. What is the traffic going outside the infrastructure, boundary environment? So because most of our customers are running a critical workload within the boundary, it's very restricted environment when it comes to pharmaceutical and life science. Their prototype or blood samples or some of the patient history, it's very difficult, right? It's very critical. All the PII, PHI, or HIPAA compliant resources should not leave the boundary. So what is AWS Network Firewall? It's fully managed AWS service with deep packet inspection, including the encrypted TLS packet. So you can inspect all the packets with the help of AWS Network Firewall. And it's fully managed for high availability. You don't need to worry about the availability for the EC2 instance. It's for the network firewall. It's fully managed by AWS. Also, you can write rules based on the domain, not just the CIDR. In this case, you have a complete visibility, CICADR rule set. There is an open set, or you can integrate some of the third-party or open source rules as well. And there is multiple deployment options, so you can have a consistent policy across your infrastructure. If it is Squid proxy, it's your responsibility to make sure you have the same policy updated in each and every Squid proxy across your infrastructure. In case if you have multiple AWS environment or a dev, pre-prod, or production, or a different AWS account. But in this case, you can have AWS Firewall Manager to push the policies across your infrastructure. It comes with AWS Managed Threat Intelligence as well. The other thing is it's built for cloud, so you don't need to worry about its scale as your traffic increase. Also, we have a limitation when it comes to the limitation. For every EC2 instance, you have a bandwidth limitation. But for the AWS Network Firewall, each and every the network firewall powered by the private link interface endpoints, every interface endpoint you will get up to 100 Gbps throughput per second. There is no bottleneck with respect to the throughput. Also, it resilient with SLA of 99.99%, so you don't need to worry about managing the complex Squid proxy running on EC2 instance. Okay, what are the network firewall features? You can, most of the time customers using the network firewall only for the URL filtering, egress filtering, and visibility and reporting and central management. You can block or allow specific domain filterings, or you can create we have a very nice rule engine with the CICADA IDS IPS rules. And we have AWS managed thread signatures, and you can use the existing AWS managed rule engines to manage, just to start with the block or allow some of the traffic. Also, you can control protocol detection enforcement, not just the URL filtering, also you can enforce certain protocols as well. You have, we will get the complete visibility with the CloudWatch metric rules, so you can forward all the traffic logs to the CloudWatch, you will get the complete visibility. Also, we can export the logs to the S3 and integrate with any APM tool. In case if you are using New Relic or Dynatrace, we can integrate with, or Splunk, we can integrate with a third-party tool. Also, it's a central management, cross-account support. You can have a multiple, you can manage multiple network firewall with a firewall manager in case if you are doing a distributed environment. So we will talk about the deployment models. We have 3 different models. We'll talk about that in next slide. Also, by default, it supports AWS CloudFormation and Terraform, so you can deploy the entire network firewall through ISE, infrastructure as a code. So this is the network firewall play. Okay, so one second. Yeah, some of the customer use cases, mostly it's for egress filtering. You can, as we discussed, we can have allow list or deny list, and with the FQDN or a particular domain name or a CIDR based or particular ports, you can have allow or deny list. Also, block vulnerable version of TLS. In case if you want to use the latest TLS enforcement, you can have a separate tool to enforce some of the TLS based deny list. Also on the other side, environment segregation for the east-west traffic, in case if you want to segregate the environment between dev and test, dev and prod, so you don't want to allow traffic between the dev and prod, right? So in that case, you can have environment segregation. So that's the second level of use cases. Also VPC to VPC, east-west traffic, and prod to dev or dev to prod if you want to restrict the traffic in this case. Also to on-premises as well. Okay, how we can place so the placement is different. You can place the network firewall in a different places, either between your network firewall and NAT gateway, or between your NAT gateway and the backend workloads. So there is a difference. So this is applicable for both egress as well as ingress traffic. So in case if you are placing your network firewall between internet gateway and NAT gateway, so the firewall will not see the actual source IP. If the traffic coming from the inside the VPC environment or the EC2 instance, the network firewall will not see the actual source IP. So it will get only the NAT gateway IP. So in some cases, if you want to take action based on the source IP, then you need to place your network firewall between the NAT gateway and the actual workload. So that firewall will see the actual source or client IP address to take the action. So it's up to you. Depends on your use case. You can place your network firewall in any of these locations. So, and when it comes to the network firewall deployment model, there are three types of deployment model, either centralized deployment model or distributed deployment model and combined deployment model. Centralized distribution model, in case if you want to have one ingress VPC, inspection VPC to inspect all your traffic, whether coming inside or going outside, you can have one inspection VPC monitor end-to-end for a east-west traffic, also north-south traffic. So east-west traffic is more into the VPC to VPC or environment segregation. If it is the north-south, then it's ingress, internet or on-premises ingress as well as egress traffic. There is some negative side on the centralized deployment we'll talk about in the next slide. So and the next one is a distributed deployment where we will deploy the network firewall in each and every VPC. So the only thing is you need to manage multiple VPC interface endpoints to make sure you are pushing the policies to all the VPCs. And the combined, you can have both in your environment. If it is a large environment where you want to monitor the east-west traffic, VPC to VPC, you can have one centralized inspection VPC environment to control the environment segregation. And for the subset of north-south, you can have a distributed deployment. So most of the time, customers use either centralized or distributed, not the combined one. So the option one is centralized deployment. For the centralized deployment model, we need to have AWS Transit Gateway. How many of you know AWS Transit Gateway? Okay, cool. So in case if this is the prerequisite. In case if you are going to set up the centralized deployment, you need to have the Transit Gateway. So the Transit Gateway act as a network hub and forward the traffic to the inspection VPC from the hub spoke VPCs or on-premises as well. If you have one or more VPC in a different environment, all of them want to connect to the same inspection VPC, the security VPC, then we can go with the centralized model. So the benefit is you will have only one network firewall. You don't need to manage multiple network firewalls. And managing the rules also very simple because you are going to manage only one particular network firewall. This is suitable for the smaller companies with, in case if you don't have much internet traffic beyond 100 Gbps, because we have a throughput limit for the interface endpoints for the network firewall is 100 Gbps per second per interface endpoints. Again. So the downside is since it's going to be the single centralized network firewall deployment, so also there is a choke, network choke. So you need to consider the the bottleneck. Also on the failure side, if something goes wrong, if you are doing some misconfiguration with network firewall or transit gateway, so it's going to impact all the environment, irrespective of environment. If you don't have much, in case if your requirement is more than 100 Gbps throughput, then you can go with the distributed. So in this case, we will have only one network firewall endpoint per availability zone. So here in the diagram, I just put only the production VPC in case if you have multiple VPC dev. So again, the dev VPC will connect to the transit gateway attachment, and then it will be forwarded to the security VPC, the inspection VPC. So for any questions? The second option is distributed deployment. The positive, so in this case, we will have a network firewall deployed on each and every VPC. So we have one network firewall in the production VPC and one in the dev. But you can manage all the firewall through the firewall manager. You can push the policies. So in this case, the firewall is deployed in the place where you have the VPC and the infrastructure. It's one-on-one scaling. And you can roll out all the firewall rules, firewall deployments in a phased manner. So you can test all the rules in the dev, and then if it is OK, then you can push the code to the production and the pre-prod. So the concern with this multiple distributed deployment model, so you need to manage multiple firewalls. And it's going to be very complex, but it's not much. Actually, you can manage the entire policy through the firewall manager. You can manage all the policies. You can push the policies to all the firewalls across the environment. I'll have another slide to compare the benefit with each and every deployment model. What is the benefit you will get for the centralized, distributed, and the combined. So, and one more thing with the distributed model, we need, so in this case, we are going to create a more and more NAT gateway. So the best practice, we are going to create a NAT gateway per availability zone, not a per VPC, so that you can avoid some of the cost related to the inter-region data transfer. So most of the customers create a one NAT gateway per VPC. That is not the good practice. So you can have one NAT gateway per availability zone in the VPC, so that you can avoid all the inter-region data transfer cost. But on the other side, you need to manage multiple routing tables and NAT gateway as well. But obviously, on the other side, you can save some of the cost. So this is the comparison between the distributed, centralized, and combined deployment models. So in case if you are, let's go with the distributed model. In this case, distributed, we are going to deploy a network firewall in each and every VPC. In this case, we cannot create, we can't do the east-west VPC to VPC environment segregation. It's not supported, but whereas it's supported in the centralized and combined. On the other side, north-south to internet or to on-prem, it's supported in distributed, north-south to internet, supported in the distributed and centralized combined model. But whereas in the north-south to on-prem, it's not supported in the distributed, because we are going to have the direct connect or VPN, site-to-site VPN in centralized environment, right? So in this case, if the traffic is going to the internet directly from the actual application VPC, then we cannot implement the north-south to on-prem. Centralized management, in case if you are deploying distributed environment, you can manage all the policies, rules through the AWS Firewall Manager. In case if it is a centralized and combined, it's a one deployment, so you can manage all the firewall, the rules through the network firewall itself. We don't need a firewall manager. So in case if you are doing a firewall manager, you can create a number of rules and share the rules through all other accounts through the RAM, resource access manager. Source IP visibility, if it is a distributed, it depends on the configuration, as I mentioned earlier. So where you are placing your firewall, whether between a network firewall, internet gateway and NAT gateway, or NAT gateway between the NAT gateway and the actual workload. So it depends on the configuration. We can able to see the source IP. If it is centralized, of course, we can see the network firewall can see the source IP. Same thing applicable for combined as well. It depends on the configuration where you are placing the network firewall. So misconfiguration risk and potential blast radius. In case if you are going with the distributed, the blast radius and misconfiguration is very lowest, because we are going to have a firewall in each and every environment. Even if you are doing some misconfiguration, it's not going to affect other environments. Whereas in the centralized, it's going to be the minimum. If it is the combined environment, the risk is very low. And cost, when it comes to cost, in the distributed, we are going to pay the cost only for the interface endpoint per VPC network firewall. Whereas in the centralized, we are going to have the transit gateway. So we need to pay the cost for transit gateway attachment and the data transfer, data processing in the transit gateway. Also the network firewall endpoints per endpoint, actually. On the other side, for the combined, same thing, including the endpoints per protected VPCs. In case you are going to, in the combined environment, you are going to have one centralized and multiple distributed. So you need to pay the cost per interface endpoints across the distributed deployment. So the cheapest option is distributed. It's up to you. Based on your requirement, you can move with any of the deployment models. These are some of the best practices when you are deploying a network firewall in your environment. Ensure you enable a symmetric routing. So meaning if the traffic going out from the VPC, the same way the traffic should come back. So if you, in case if you are going to asymmetric, then network firewall will drop the traffic actually. So this is applicable when you are placing the firewall between the NAT gateway and the workload. So always don't use the stateless role. Try to use the stateful so that you don't need to manage multiple roles. And you can create a custom cicada rule just to get more familiar. You can have multiple use cases. In case if you are going with AWS managed rule, you cannot edit. So better we suggest to go with a custom cicada rule. It's an open source method. It's a free editor. You can create your rules with some capacity level. Also, you can have a group the rule groups. You can create a multiple groups and combine all the groups into the network firewall rules into the group. You can assign to the environment wise or the VPC wise. Just to avoid all the traffic going through the NAT gateway, make sure you set the proper home network. Home network means your VPC environment IP within the environment. So you need to make sure you set the home net variable is properly. Otherwise, the network firewall will drop the traffic. So when we are deploying the network firewall, we don't want to take action whether allow or deny. So we just want to understand the traffic pattern. What are the traffic going outside the environment? So we actually enable the alert before we take action. So for a couple of months, we observe the environment, understand what are the traffic going outside, or whether in coming in ingress traffic, and then based on that, we'll take action. We'll create a rules, cicada rules for egress as well as ingress. So always start with understanding the rule before take action. And on the other side, always we push the logs to the CloudWatch and S3 log, so that all the logs, whether it's allowed or denied, so we enable all the logs, so that we, in case something goes wrong, we can take a look, we can investigate later. And the other one is for the cost-wise, always use the VPC interface endpoints for S3 and DynamoDB to optimize the cost. You don't need to access the DynamoDB or S3 through the internet. Then you are going to pay the internet data transfer cost. If any data going outside the environment, you need to pay the cost for the egress. So in this case, you can reduce some amount of traffic traversing network firewall just to reduce the cost in case if you are using S3 and DynamoDB gateway endpoint. Also, some of the VPC CIDRs, some of the application you really don't need the internet access. For example, you have one application is just going to access some of the data from DynamoDB or going to fetch some data from the S3. In this case, you can enable an endpoint and you can remove the routing table entry to the network firewall or the NAT gateway. This also increase the security. On the other side, you can save some of the cost. And make sure on the symmetric we spoke. Let me show you a quick demo. So I just created one VPC. This is a distributed model. Because for a demo, I just want to keep it simple. I just deployed the network firewall in a distributed model. We have one VPC with multiple subnets, 2 public subnet, 2 firewall subnet, and 2 private subnet. So all the private subnet traffic pointing to the NAT gateway at this moment, I have not configured the firewall. Here I have the network firewall implemented with the default action to deny all the traffic. But you can modify the rules, whether allow or deny based on your requirement. For now, I'm going to deny all traffic. Demo policy. So here I have a stateful rule group, deny all traffic if it is going through the network firewall. So for now, let me log into the EC2 instance. Okay, let me change the routing table first. Internet is really slow. Sorry about it. So this is my NAT gateway IP. All my traffic going through the NAT gateway, 44.198.126.209. So if you try to access any website, it's allow you to access the website. Let me try something else. Okay, so I'm going to change the routing table for the egress traffic through the network firewall. So I already have the network firewall implemented, created the policy to block all the traffic, but you can change the policy. Depends on your requirement. So whether you can allow certain URLs or you can deny all traffic or deny specific bad URLs. Now let me change the routing policy for the private subnet. So this is the private subnet. If you look at the traffic, it's pointing to the NAT gateway. Let me change the traffic to the load balancer interface endpoint. So now all my egress traffic going through the network firewall. Let me go back to the EC2 instance. Let's refresh the page. Sometimes it takes a few more seconds. Okay. Just 2 more minutes. Okay, I'll show you this later. For some reason, it's taking some more time. Any other questions? So if you have any questions, you can ask me. I'll be here for another 1 hour, so you can ask me anything. Yes?
It seems that the distributed mode of deployment has many advantages, except that it's complicated to manage the. So I was asking that it seems the distributed deployment has all the advantages, except that it's complex to manage. So is it possible to offset that by a sort of script or something?
Yeah, you can create a multiple rules through the firewall manager. You can push it through. It's not much complicated, but little bit complicated compared to the centralized one, but not much. You can have the script or through. You can deploy everything through ISE.
But it's much cheaper than the centralized.
Yes.
Yeah. Thank you.
Cost-wise also is cheaper. Any other questions? Thank you all. Thanks, Join.